We begin with the exact same number of particles on each side of the membrane. At the top of the box, we indicate the number of each type of particle on each side. In these animations, the front wall and the back wall are invisible. What may look like erratic particle motion is really particles bouncing off the invisible front and back walls. The small red particles are able to pass through the holes in the membrane, whereas the large white particles are not. In equilibrium conditions, there will therefore be some red particles on both sides of the membrane, whereas all the large white particles will always only be on the right side. This means that in an equilibrium condition, there will be a greater number of total particles on the right side of the membrane than on the left side. We call this process osmosis. Suppose we want to reverse this process and move all the red particles back to the left side, or at least as many red particles as we can. We can do this through what we call reverse osmosis. If the piston on the right moves towards the left, we can try to force the red particles through the membrane back to the left side. Notice the numbers at the top of the screen for the red particles on the right side of the membrane. The number of red particles on the right side of the membrane goes down to close to 0. Next, we will show reverse osmosis in a different way. In the next example, there will be 0 gravity. All the balls are able to pass through the membrane, but the square white particles are not. Initially, there is a net migration of balls from the left side to the right side. But once we apply a force to the wall on the right, there is a net migration of balls from the right side to the left side. This can be seen in the numbers at the top of the screen. The white particles can represent salt ions. The red and blue balls can represent a fluid. In reverse osmosis, we push a fluid with dissolved salt ions through a membrane, which allows the fluid to pass through, but blocks the salt ions. In all the simulations in this video, all particles have the same density and interact only through perfectly elastic collisions. Suppose the red balls represent water and the white balls represent salt ions. The process of osmosis causes more water molecules to move towards the side with the salt ions. In all the examples in this video, we demonstrate both osmosis and reverse osmosis by using simulations with no attractive forces between any of the particles. The process of osmosis causes more water molecules to move towards the side with the salt ions. The process of reverse osmosis allows us to reverse this and to generate pure water from salt water. Suppose the red balls represent water and the white balls represent salt ions. Reverse osmosis can allow us to generate pure water from contaminated water. Much more information about Osmosis is available in the video Osmosis as You Have Never Seen It. Thank you to everyone supporting us on Patreon. Your support is very much appreciated.